Bismillahirrahmanirrahim. I am back on the YouTube channel after a long time. Although I had no issue coming back, but I just delayed it purposely. Anyhow, let us start it with the first slide. You know my introduction is already in there. The present set of these videos, right, is comprised of four parts: Part 1, Part 2, Part 3, Part 4. And these parts will come on the video one after the other. Anyhow, this part 1 is actually starting with this field experience on corrosion and corrosion control in thermal water desalination plant. This slide shows my experience, both educational and field experience. You can read it all in there yourself. The most important part of this slide and my experience is that I have worked in many industries, not only in one country but many countries, and I have collected all the information I needed, right, and put together to extend my YouTube channel's videos and presentations. This slide shows types of thermal water desalination plants discussed in this presentation. Generally, there are four types of desalination plants. One is the multiple effect evaporators, multi-stage flash evaporators, vapor compression, and hybrid combining both multiple effect evaporators (MEE) and vapor compression water desalination plants. This slide shows the function of thermal water desalination plants, mainly their principle. Thermal water desalination plants work by evaporation and condensation, mostly using seawater as feed. These plants incorporate energy-efficient approaches to maximize production per unit energy input. This slide shows the location of thermal water desalination plants. These plants are mostly located at the seacoast, where water input as feed and concentrated water discharge as brine has free access. Water discharge is concentrated seawater with original input as feed based on design strategy and concentration factor. This slide shows the design strategy in water desalination plants. Number of units having identical design, metallurgy, and operating parameters are put in parallel to meet production targets and water discharge concentration factor. This slide shows multiple effect evaporators, water desalination plants, operation and principle. These plants are relatively low temperature, works on the principle of thin film evaporation, where the feed water is introduced at slightly less than atmospheric pressure for rapid and immediate vaporization. The heat from the condensation step of one effect is utilized to supply vaporization heat for the following effects. The next effect is at slightly lower pressure and temperature. This slide shows multiple effect evaporators, water desalination plant operation and principle. The gradual reduction in heat transfer results in a much greater yield of product water from a given quantity of thermal energy. This slide shows a design strategy of multiple effect evaporators, water desalination plants. MEE plants are designed using vertical or horizontal tubes. Configuration depending on the type of heat transfer surface and the direction of the brine flow relative to the vapor flow. MEE plants are also designed in stack configuration where the brine flows from top effect to the lower next effect by gravity. Hybrid MEE WDP are built in the form of vertical tower with reverse osmosis to cut down the water production cost, enhance the performance ratio, and curtail space requirement. This slide shows a simplified configuration of three effects of vertical tubes, multiple effect evaporators, water desalination plants. The configuration is self-explanatory, so you can go through this and read it on your own. And everything is shown in there, how the vapors and the feed it flows, and how the concentrated feed water goes back to the sea or the drain. This slide shows simplified configuration of horizontal tubes, three effects, MEWDP. Again, this configuration is self-explanatory based on the first, second effect, and third effect. All those information as you may require is visible on the configuration itself. You can please go through this one and you understand how the feed enter the plant as seawater and how the brine comes out as a discharged water. This slide shows the simplified configuration of stacked multiple effect evaporators, water desalination plants. This configuration is again self-explanatory. You can see that how the feed water enters into the stack and how the feed water sprayed right on the one evaporator, then come to the next evaporator, then come to the next evaporator, and then eventually it produces the distilled water or desalinated water, and the brine goes back to the sea. This slide shows a MED vertical tube towers come reverse osmosis hybrid water desalination plant. Again, this figure is self-explanatory. It is 500,000 tons per day hybrid desalination plant, and you can see all the ports are marked in there, and then there is a legend on top which you can see that which port is talking about which port. This slide shows a multi-stage flash evaporator water desalination plant operation and principle. MSFWDP is a high temperature evaporation plant designed to draw heat energy from external source. Steam is taken as heat energy from an external source, heat water, and flash it in stages set at successively lower pressure and temperature. Seawater as feed is fed at the normal atmospheric pressure to tube internals and the flashes at lower pressure to tube externals in flat chambers for condensation. This slide shows a simplified configuration of MSF, WDP, and pre-treatment section. This configuration is self-explanatory, and you can just look at it from where the feed comes in and where the product goes out and where the brine is destroyed. Pretreatment section in MSFWDP. Pretreatment section in MSFWDP is comprised of an acid dosing, decarbonator, and deaerator. This slide shows a simplified configuration of MSFWDP with scale inhibitor dosing, no deaerator, and decarbonator. Because all the scales formed in there are actually inhibited by adding a scale inhibitor into the section as you see in the figure. This figure is again self-explanatory, and you can read right how the first stage and the second stage might go to the end stage. It works right along with the chemical dosing. This slide shows a boil cleaning system for tubes internals in MSFWTP. Boil cleaning system keep tubes internal free of scale deposits, and that in turn provides controlled under-deposit corrosion on tube internals, maintaining a flow rate. Ball cleaning is very useful in two modules, long tube MS of water desalination plant. This slide shows a simplified configuration of tubes internals ball cleaning system in MSF WTP. In this configuration is self-explanatory. It's showing the brine heater and heat recovery section and the heat rejection system, right, as the cleaning system in operation. The role of deaerator and decarbonator in two modules long tube MSF water desalination plant. Deaerator removes oxygen and decarbonator removes carbon dioxide from seawater feed. However, some carbon dioxide and oxygen remain in the seawater to cause corrosion to flash chambers internals in the flashing zones and tubes externals in the condensation zone. This slide shows what vapor compression water desalination plant using mechanical energy and thermal energy to compress vapors. Vapors are drawn from distillation vessels and compressed to raise the temperature of the exhaust vapors. Vapors are passed over a heat exchanging condensers where vapors are returned to the liquid state as product water. Heat removed in the condensation is returned to the raw water to assist in producing more vapors. These plants work at lower temperature using thermoplastic materials, therefore pose no corrosion threats. This slide shows a simplified configuration of vapor compression water desalination plant with scale inhibiting closing system. So again, this configuration is self-explanatory. You can read it how the feed enters and where the brine comes out and how the vapors they can flow right from the condensation and evaporation zones into the product water. This slide shows the simplified configuration of four effects thermocompression water desalination plant. Again, this configuration is self-explanatory. It has four chambers, one, two, three, four, and there is a legend that explains its different parts, right, of this plant. This slide shows corrosion and erosion in thermal water desalination plants, both in MEE and MSF. The internal erosion corrosion, external corrosion, and external erosion corrosion are a common type of corrosion in these water desalination plants. These are last slides of the part one of this presentation. This slide shows corrosive and erosive constituents in multiple effect evaporator water desalination plant. The corrosive elements are the dissolved seawater salts, mainly chlorides, dissolved oxygen gas, temperature, scale forming components is less of an issue of corrosion. Scaling is observed at heat transfer surfaces and falling seawater velocity through sprinklers.